Hello to my fellow friend and our lecturer, Dr. Nordin. So today I will be presenting fluid and dimensions. So what is fluid? Fluid is a substances that continually deform under applied shear stress or external force. It can be gas or liquid. The physical properties of fluid are densities, specific weight, specific gravity, surface tension, and viscosity. So we'll go through one by one. So what is density? Density is a measure of mass per volume. The equation is P equals to mass per unit volume. Specific weight is the amount of weight per unit volume. The equation is specific weight equals to weight per unit volume. Specific weight can be equals to density times gravity. The unit is Newton per meter square or pound per feet cube. Specific gravity is the ratio between the density of an object and water at 4 degrees Celsius. For specific gravity, it can be specific weight of substances divided by specific weight of water at 4 degrees Celsius, or density of substances divided by density of water at 4 degrees Celsius. So the specific weight of water at 4 degrees Celsius is 9.81 kilonewton per meter cube or 62.4 pound per feet cube. The density of water at 4 degrees Celsius is 1000 kilogram per meter cube or 1.94 slugs per feet cube. The surface tension is the tendency of liquid surface to shrink into the minimum surface area possible. Surface tension of equation of surface tension is 1/2 times F over L. F is force while L is length. For pressure is the force exerted per unit area. The equation is P equals to F over A. F is force, A is area. Viscosity, for viscosity, there are two types of viscosity, which are dynamic viscosity and kinematic viscosity. Dynamic viscosity is the measure of fluid resistance when an external force is applied. The equation is shear stress equals to dynamic viscosity dc over dy. dc is unit velocity, change in unit velocity. dy is change in unit distance between layers. For kinematic viscosity is measure of fluid inherent resistance to flow when no external force acting on it. The equation is kinematic viscosity equals to dynamic viscosity over density. So in fluid, there are two types of fluid, which is Newtonian fluid and non-Newtonian fluid. Newtonian fluid is viscosity remain constant and independent of the amount of shear stress applied at constant temperature. Examples are water, air, and glycerol. From a graph shown, as you can see that the shear stress and the shear rate are always proportional to each other. For non-Newtonian fluid, its viscosity is dependent on velocity gradient in addition to the condition of fluid. When shear stress is applied, its viscosity change, either increase or decrease. Non-Newtonian fluid consists of time-dependent non-Newtonian fluid and time-independent non-Newtonian fluid. Pseudoplastic and dilatant fluid are time-independent non-Newtonian fluid. For pseudoplastic, its viscosity will decrease when a high stress shear stress applied. Examples are pin, ketchup. For dilatant fluid, it acts the opposite, which is the higher the shear stress applied, the higher the viscosity, such as blood. As these are the graphs showing the flow behavior of Newtonian fluid, pseudoplastic fluid, and dilatant fluid. For rheopactic and thixotropic fluid, they are time-dependent fluid. So for rheopactic fluid, the higher the stress applied, the greater the velocity. Examples are cream, gypsum paste. For thixotropic fluid, the higher the stress applied, the lower the viscosity. Examples are cosmetics. So now we will proceed to surface tension. Surface tension is measured as the energy needed to increase the surface area of liquid by unit of area. So surface tension happens due to the imbalance of intermolecular electric force, cohesive force between molecules. It will push the molecule inwards to form a bulk liquid. So elastic modulus measures an object or substance resistance to being deformed elastically when the stress is applied to it. The equation is E equals to stress over strain. The E is Young modulus. Compressibility is the change in volume of the substances that is subjected to a change in pressure on it. Normally, we use Young modulus to calculate the compressibility. So vapor pressure is pressure exerted by vapor when it is in equilibrium with a liquid or solid. The pressure exerted by the vapor molecule on the wall of container during the collision is called vapor pressure. So now we approach the dimensions. So what is dimensions? Dimension is a property that can be measured or calculated by multiplying or dividing other dimensions. The examples are length, mass, time, volume, velocity. And for the dimensional homogeneity, equations must have a quantity of the same unit on both sides. For dimensional homogeneity, I will explain later. So as you can see that these are the primary dimensions. Which are mass, length, time, temperature, electric current, amount of light, and amount of matter. So now we will proceed to dimensional analysis concept. So dimensional analysis concept is the study of relationship between physical quantities with the aid of dimension and unit of measurement. We use dimensional analysis concept to convert a quantity written in one unit to another unit which is equivalent. It helps to reduce number of variables and also reduce the perimeter to 1. So this is an example. Let's say we need the dimension of length. But however, we are given L to the power of A, M to the power of B, T to the power of C, I to the power of D, O to the power of E, N to the power of F, and J to the power of G. So however, as we know that length is just a length, right? So we can write the power of other variables except L to be 0. So M0 will be equals to 1. Equals to 1. So we will have the same unit at the left side and the right side. So dimensional similarity, there are 3 types of dimensional similarities which are geometric similarity, kinematic similarity, and dynamic similarity. For geometric similarity, it is only established when the model and prototype are geometrically similar, if and only if all body dimensions in all 3 coordinates have the same linear scale ratio. For kinematic similarities, it requires that the model and prototype have the same length scale ratio and same time scale ratio. Thus, the velocity scale ratio will be the same for both. And last but not least, for dynamic similarity, it exists only when the model and prototype have the same length scale ratio, time scale ratio, and force scale ratio. So this is an example of principle of dimensional homogeneity. As you can see that we are given equation D equals to D naught plus V naught T plus 1 over 2 AT squared. As we know that the dimension of displacement is length. So we will be changing it to dimension format. So length equals to length, DO is length, dimension of DO is length, VO is length over T, length over time, and T time is T, capital T, plus length over T squared is A. We will ignore the 1 over 2 as unit is not important. It's not included in calculations of dimensions. And also the last one is T squared, which is a capital T squared. So after cancelling the TT and T squared, we'll be getting length plus equals to length plus length plus length. So as we can see that we have the same unit at the left side and the right side. So now I'll be showing you the method of repeating variables and Buckingham-Pi theorem. So before proceeding, we have to know the fundamental dimension. As fundamental dimensions, they are used a lot in Buckingham-Pi theorem. So the fundamental dimensions are length, mass, time, electric current, temperature, amount, and luminous intensity. So now we'll be proceeding to Buckingham-Pi theorem. When using Pi theorem, we have to follow this. First one, count how many variables in problem. Second one, count how many dimensional quantities involved, the basic dimensions. Third one, we will be using n minus m. M is the number of variables, while n is the number of base dimensions involved in that problem to get the number of pi terms in problem that we have to calculate. The fourth one is select repeating variables. When we are selecting repeating variables, the repeating variables cannot be dimensionless. Example as If there is a unit as 1, we cannot choose it as 1 is dimensionless. It doesn't have a unit. So second is we cannot choose a repeating variable that have the same overall unit. For example, we can't choose height and width as they both have the same overall unit, which is length to the power of 1. So now we will proceed to questions. So it's the questions. Drag force is a function of viscosity, velocity, density, and diameter of sphere for a fluid flow. Determine pi groups. We'll be using Buckingham pi theorem to solve this problem. So step 1, we have to list all the variables in problems. The variables in the problems are drag force Fd, density P, velocity V, viscosity micro, and d diameter. Step 2, we will express each of them in terms of basic dimensions. The dimensions of drag force is m times L over T squared. For V is L over T. For D is L, length. For viscosity is mass over length times time. For density is mass over length cubed. Step 3, we will find number of pi terms. As we know that there are 5 variables in this problem. So the m is 5, and n is the dimensional quantities involved, which is m, l, and t, mass, length, time. So there are 3 dimensional quantities involved. So the pi term will be equal to 2, which is n minus n. 5 minus 3 equals 2. So we have to find that 2 pi terms. So step 4, we have to determine our repeating variables. So in this case, in these questions, the repeating variable can be density, velocity, diameter, or viscosity, diameter, or viscosity, diameter, density. So we'll proceed to step 5, compute. So in this case, I use density, velocity, diameter as repeated variables. So for pi 1, we have to write pi 1 equals to p to the power of x times v to the power of y times d to the power of z. And then we have to add one more variable, either fd or viscosity. So for pi 1, we'll be using fd. So we will write them in dimension format. So it will be n times length to the power of negative 3 times x to the power of x times length to the length times t to the power of negative 1, and then bracket to the power of y, and then times length to the power of z, and times bracket m times length times t to the power of negative 2. So now we'll be solving it one by one. So as you can see that for m, there's just x plus 1. The x is from the px there. So it will be the m will be shift out, will be mx. So it will be x plus 1. The 1 is from fd. So x was equals to 0. So x will be negative 1. And for t is equals to negative y, negative 2 equals to 0. So y will be negative 2. So we have to sub m and the x and y into the equation L. So we will find out z equals to negative 2. So for the pi 1, we will be written in, for the pi 1, we will write in fd drag force over p x vy dz, as we find that z so I'll be writing pi 1 equals to drag force over px vy dz. As we have found that x equals to negative 1, z equals to negative 2, and y equals to negative 2. So we will just substitute them inside here, the equations, and then become like this: fd over p times d to the d squared times v squared. So equals to when we write them in dimensional format, it will be m times length times t to the power negative 2 divided by bracket m times length to the power negative 3 times length square again times t to the power negative 2. So when we do the mathematical calculations, it will become 1, which is dimensionless. The answer we find we have to find for both pi must be dimensionless. So we'll be using p to the power of x times d to the power of y times v to the power of z times viscosity. As just now we have used the drag force already, so now we'll be using viscosity. So the dimensional format equation is bracket n times length to the negative 3 to the power of x times L to the power of y times L times t to the power of negative 3 bracket to the power of z times n times L to the power of negative 1 times t to the power of negative 1. So we will get m is x power equal to 0. So m will be equals to x will be equals to negative 1. Sorry, it's not m. And for the L is negative 3x plus y plus z minus 1 equals 0. For t is negative z negative 1 equals 0. So z equals negative 1. So same thing happened. We have to substitute m and x and z into L equations, and then we will get y equals negative 1. So for pi 2, we will use the same thing, which is equals to viscosity divided by p times d times dy times d to the power of z, as the m x y and z is negative 1 negative 1. So it will be p1 p to the power of 1 d to the power of 1 v to the power of 1. So the dimensional format will be n to the power of n times will be n times L negative 1 to the n times L to the power negative 1 times t to the power negative 1 divided by bracket n times L to the negative 3 times L times t to the power of negative 1 equals to 1, which is dimensionless. Hence, n1 equals to f and 2. So we have to write in the final format, which is fd times bracket p times d square times v square equals to f bracket u divided by p times d times v. So these are the list of the steps of method of repeated variables. These are the steps of doing the Bankingham pi theorems questions. So step 1, list all variable as what I have showed just now. Step 2, express each variable in basic dimensions. Step 3, determine the required number of pi terms. Step 4, select a number of repeating variables. Step 5, form a pi term. Step 6, repeat step 5. And step 7, make sure all resulting pi terms are dimensionless, which means the answer you get must be dimensionless. And step 8, express the relation between both between the pi terms. So these are the list of dimensional terms. Actually, there are a lot, but I'm just picking some and put in here only. So this is the end. Thank you.